Hi, this is Ali, and today we're going to be solving four kind of hard, kind of easy math questions regarding trigonometry. So, the first question we have over here, it says, determine all possible values for values of theta for 1 over 2 secant theta equals 1 over square root of 3 secant theta. If theta is more than or equal to 0 or less than or equal to 360. Now this is a fairly easy question, but the real trick here is that it has multiple answers, right? So what we can start by doing is we could first simplify it. So for question 1 here, so 1 over 2 secant theta equals negative 1 over square root 3. Sorry, I couldn't read the negative. I was looking through the camera. Let me just adjust. 1 over 2 secant theta equals negative 1 over 3. It's pretty simple. So to simplify this, we have to divide this side, the right side, by 1 over 2, which would make it become secant theta equals negative 1 over square root 3 times 2, which will result in negative 2 over square root 3. Yeah, that's it. Secant theta equals negative 2 over square root of 3, right? Now, if we remember correctly, secant theta equals 1 over cos theta, right? So by this logic, we can invert this, and cos theta would equal square root 3 over 2 minus square root 3 over 2, right? So we're getting somewhere here, all right? Now, since the range of our angles is since the range of angle theta is over or equal to 0 or less than or equal to 360, that means we have to encompass all the quadrants, right? So if we go ahead and draw a Cartesian plane here real quick, let me just use a protractor. If we go ahead and draw a Cartesian plane, we can see the 4 quadrants we have to cover. Now A, S, T, and C are the words I use to cover them. So A means all of them, all of the trig ratios in this quadrant are positive. T means only tangent is positive. C means only cosine, and S means only sine is positive. Alright, so in this case we have cosine, and cosine is negative. So that means if cosine is positive here and positive here, it can't be in these quadrants, it can only be in this or this quadrant. Now what's also important to note is that for this question, no calculators are allowed. So what we need to do is we need to use a special triangle to solve theta for cos square root 3 over 2. Now this is really simple. There's a special triangle, the 30-60 triangle, which is like this. The triangle over here says that this side is square root 3 and the hypotenuse is 2 and the bottom side is 1, based on these. So these are just ratios. Now you could scale them to any triangle you want, but in this case we don't need to scale them, we can just use these ratios. So we realize that if cos theta equals opposite, if it's SOHCAHTOA, right? So based on SOHCAHTOA, we realize that it's adjacent over hypotenuse. So adjacent over hypotenuse means that if the adjacent side is square root 3, the top part, and the opposite is, the hypotenuse is 2, then the angle must be 30, because the adjacent side of 30 is square root 3 and the hypotenuse of 30 is 2. Alright, so we've concluded that theta equals 30. Alright, cool, that's our answer. But it's not, because cosine has a negative sign. Theta cannot be here because it will be positive here. As we said, theta cannot be in the first or fourth quadrant. So therefore theta has to be in the second or third quadrant. So what we do to convert an angle from its place in the first quadrant to the second quadrant is we do 180 degrees minus 30 degrees over here, and we get 150 degrees, which is the angle over here with 150, and it forms a 30-degree angle here, which forms a 60-30 triangle over here, resulting in square root 3 and hypotenuse 2 and 1. Alright, so that's our first angle, that's number 1. Now there is another angle because it can also go in another quadrant. Now to bring it in the third quadrant, we simply add 180 plus 30. and the result of this is 210 degrees, which would be around here. It will form an angle of 210. It will form an angle of 210, which would result in a 30-degree angle right here, forming another 60, 30 triangle, blah blah blah, etc. So our two angles are 150 and 120 at this point. All right. Now that is the first question done. So therefore, the possible values of theta are 150 degrees and 210 degrees. All right. Good. Great. Full marks. All right. Now, moving on to the next question over here, moving down a bit, we can start up our second question, number 2. So now our second question actually gets quite a bit harder fundamentally. So the second question is still rather easy though. It says, solve ABC if angle A equals 38 degrees, A equals 30 centimeters, and C equals 42 centimeters. Now, the interesting part of this question is, similar to the previous question, it can also have multiple answers. All right. These answers, the other variations of the answer, are known as the ambiguous case of the sine law. All right. So for 30, what we can do is we can follow the cosine law rule, the sine law rule, and realize that if A is acute, so if A is less than 90, right? Then if A is acute, there are two possible triangles to be made here. One is a triangle in which, so let's draw the first one. So one is if A over here, right? Let's imagine A is right here, and what was the other one? B is up here, and C is here. So if A is 38 degrees, and B is undefined, so they didn't give us B, they didn't give us C either, they only give us A. If A is 38 degrees, and 42 centimeters is what C is, and A is 30 centimeters, C could either be here, or it could be here. So we could have a triangle that has one obtuse angle, or a triangle that has 3 acute angles in this case, right? So this is case 1, and case 2 would be a triangle that looks more like this, somewhat, yeah. If I could use a ruler to draw it, it would look better, but you get the point. It's enough. All right. So if a triangle is like this, then this angle C, is an obtuse angle. All right. All right. So back to what I was saying. If C is obtuse here and A is 38 degrees here, we have a different triangle. All right. But both of them are valid under the sine law, which is what is known as the ambiguous case of the sine law. All right. So now we have to solve for each basically. So we can use the sine law to solve for A, as if C is normal. So what we do to solve here is we just use the sine law. So we put sine of A over 30 degrees, right? So sine of A over 30, which is over here, so angle 38 over 30 would equal sine of C over 42. All right. So angle C would basically be equal to inverse sine of sine 38 over 30 times 42. All right. So by this logic, C would be equal, if we punch these in the calculator and we calculate them to the nearest whole number, C would be equal to 60 degrees. So in this case, C is 60 degrees. All right. Now, if we subtract 100, and I don't know if you guys can see this, but yeah. So if we subtract 180 by 60 plus 38, which is these two sides added together, we can find the last angle, which is angle B. So angle B equals that, which in this case would result in 82 degrees. All right. So now that we have 82 degrees over here, we can solve for side B very easily. So we can just use the sine law. We have to make sure to include C in our equation. Now we can start calculating side B by putting sine B this time the side over the angle, because we want to solve for the side, equals sine 60, which is C, over 42. Alright, so then what we get is B equals 42 over sine 60 times sine 82. Now at the end, if we plug all of these into a calculator, what we get is that B equals 48 centimeters. Alright, so this side over here, 48 centimeters. Alright, that is case number 1 of our triangle. We are good, we are golden, and we are done. Alright, not so fast. We are actually missing something. Is case 2. So in order to solve the other possible angle C, what we would need to do in this case is to subtract 180 by 60, and we would get 120 degrees. So that's the obtuse case of C, because if you consider this a triangle, and then C, the other C is like that, right? You feel me? The other C is like that. Sorry. Yeah, the other C is like that. All right, the other C is on the other side. Okay. Then, if the other triangle is like this, if this is A and that's B and that's C, then this whole thing is 180. So if we subtract 180 by 60, we get 120 here, which is this which is the angle C over here, and we could solve this. So technically, this is another part of that. So I just basically split them so it would be easier to visualize and calculate. But they sort of relate together. So then what we do with this newfound angle 120 is the same thing. We subtract 180 minus 120 plus 38, and that would equal 22 degrees. All right. Lastly, we can use the 22 degrees to solve using the sine law. So sine of 22, which is B, equals 42 over sine 120, which is C, and this way B equals 42 over sine 120 times sine 22, which equals approximately 18.2 centimeters when rounded to 1 decimal. All right, so this is side B, 18.2 centimeters, and B has an angle of 22 now. So yeah, that's the two cases. Case 1 is B has an angle of 82, C has an angle of 60, and the side B is 48. Case 2 is that B has an angle of 22, and so therefore this. The therefore statement is that, basically. Therefore, these are the two cases. And side B is 18.2 centimeters. All right, so those were the first two questions. We're halfway done. Let's move on to the second part, which, not gonna lie, I think this part starts off easy but ends up becoming harder. But you know, those are all just relative. This is all pretty easy. So the first question over here, which I did not have enough time to solve, was given that cos A equals negative 3 over 5 and sine B equals negative 12 over 13, and both angle A and angle B are in quadrant 3, determine the exact value of the expression sine A times tan B over tan A times secant B. Now the tricky part here, the only tricky part of the question, is that they give you cos A and they want you to solve for sine A, which is, you know, on the surface it looks difficult, but once you get into it, it's actually pretty easy. So we're gonna get our sheet of paper out again, you know, classic handy dandy tool, and we're gonna start drawing a diagram. So for 3, basically the quadrant part of the equation is actually very important. The fact that they're both in quadrant 3 is actually quite significant. So if we draw a Cartesian plane again, a astique as I like to call it, it makes me remember it, is still apparent. So if this is quadrant 1, 2, 3, 4, right? They're both in quadrant 3, so none of them are in the other quadrants, right? So there are only 2 angles. There's angle A, right, and there's angle B. So I'm going to draw these in separate Cartesian planes just because they're going to be overlapping pretty much, unless they're still going to overlap. Their values are going to overlap. So that's angle A, that's angle B. All right, so let's imagine this is angle B. All right, and this is angle A. Now, all right, so if cos A, that I messed that up. Okay, cos A equals -3/5. Okay, and sine B equals 12/13, -12/13, and they're both in the third quadrant. That means they are in the right quadrant indeed, because cos, they didn't even need to say they're both in the third quadrant. Well, I mean, they could have, but you know, we could still figure it out from this. So negative here, this is AS, so T, 10 is the only thing that's positive, so these two are both negative and they should remain negative. Now cos of something usually means x over y, it means x over r, which is like the length of the arm, and sine means y over r. Okay, now in this case, that means that if this were to be a right angle triangle, y in this case is 12, -12 actually, because it goes down, and the hypotenuse can never be negative, and r is 13, so this becomes 13. So now we need to solve for that. And in B's case, since sine B, I'm sorry, this was supposed to be, okay, so let's make this angle B. I'm sorry, I messed that up. So if that's A, then that's B. Things get quite different. So that is angle B. All right. So now here, if r is 5, okay, so this is 5, and cosine means x, so the x is -3. Yeah, because negative on the number line, right? So -3 and 5, we need to solve for this. So to do this here, we can just use the Pythagorean theorem. So if this is the hypotenuse, 5 squared minus 3 squared equals, let's call it O squared, because O. And then O here, if you plug it in if you punch the numbers in, so this is 9, this is 25, 25 plus 9, 25 minus 9 is 16, so square root of 16 is 4, because, you know, it can't be negative, it can't be a negative triangle, so it has to be positive, so it's 4. So this equals 4 right here, and on this side we can use the same thing, 13 squared minus 12 squared equals O squared, and O in this case, after you plug in the numbers, would equal 5, because 169 minus 144 equals 25, square root of 25 is 5, so boom, boom, 5. Okay, we got another 5 over here. So now if we're requested to find the value of the expression sine A tan B divided by tan A secant B, all we can do is just use the information we just got. So sine A would be equal to y over r, A. So if A's y is -12 over here, if A's y, this is A now. So if A's y is 4, okay, then we can just use 4. So 4 over 5, -4. So this 4 that we got over here, since it is translated into the third quadrant, becomes a -4. All right. Sorry, I realized that after continuing with the question. So we got -4. Now -4 over 5 over here is basically sine A. Now times tan. Well, we're not supposed to write 10, but times tan of B, it would be y over x of B. So B's y is -12 over x is 5, so negative. But in this case, tan is positive, so it becomes 12 over 5. So, you know, technically, since 5 over here is in the negative side, so this becomes negative. So negative over negative is positive. But you know, this fits the rules. Memorizing the rules fits easier into my mind. But that's the math behind it. So this divided by 4 over 3, because tan of A over here is 4 over 3, and now these are both negative. Negative on top of negative is positive, all because it's the third quadrant. Tan is positive, times secant b, secant equals 1 over cosine. So we just flip cosine, basically r over x. So secant b will equal negative 13 over 5. All right. So now, if we simplify this, it would equal 48 over 25, negative 25, times 15 over 52. All right. Negative 52 to be specific, because they both have negative signs. So I'm just trying to, I just multiplied these two and then flip the sides so we could divide them. All right. So now once we simplify this further enough, this becomes negative 5, this becomes 3, this becomes 13, negative 13, and this becomes 12. So this becomes 36 over 65. And it becomes positive because the two negatives cancel each other out. So therefore, the result is 36 over 65. That 0 did not look like a 5. All right. So onwards to that's the third question. Onwards to the last question over here. We have, so the answer is 36 over 65 for that one. And then for number 4, number 4 is an interesting question. So it reads, Melanie is standing on the 10-meter diving platform. Her coach is on the ground to the left of her, while her parents are on the ground to the right of her. Her coach is looking at her at an angle of 38 degrees with the ground, while her parents are looking at her at an angle of 30 degrees with the ground. The angle at the base of the platform between Melanie's coach and Melanie's parents is 105 degrees. So A, draw the diagram to represent the solution. B, how far apart are her coach and her parents to the nearest meter? All right. So this question requires a lot of drawing compared to the previous ones. And so let's go ahead and start with the diagram. So a frontal view of what is happening in this situation would look something like this. So there will be a triangle, and that is the diving platform, 10 meters long. And since her coach is to the left, the coach can be here and parents are to the right. Now, the parents are looking at her with an angle of 38 degrees. The parents are looking at an angle of 30 degrees to the ground, which would be here, 30 degrees. This is a 3D shape, right? And the coach is looking at an angle of 38 degrees, all right? Since the angle between the base of from the base of the platform to since the angle here, the base of the platform, to the coach, and between the coach and the parents, all right? Sorry, I'm just gonna read off the question. The angle at the base of the platform between Melanie's coach and Melanie's parents is 105. This whole thing is 105. All right, we could use this diagram. Now this is the front view. Just to make it clearer, I'm gonna draw a different view, like a side view. So this is the parents' side. All right. Now from the parents' side, this is what they see. They see a 10-meter diving pole. All right, and then these are the parents right here. P, represented by P. All right, 10 meters. Now, sorry, I got to move that out. Now the parents are here, and they're looking at it from at an angle of 30 degrees from the ground. Now on the other side of them, the coach is here, and he's looking, and it's all good and dandy. And there's an angle of 105 degrees between them. All right. Now from the coach's side, it's basically the same exact thing, except the angle is different. Sorry, I'm just gonna draw a rough. So 90, these are both 90 degrees, by the way, because the pole is perpendicular to the ground. And that makes our lives a lot easier than if it wasn't. So 38 degrees, this is the coach. There we go. Those are the parents. And boom. All right. So now to solve this, we basically need to solve this distance. Or no, sorry. We need to solve this distance up here, because then we could use the angle 105 to solve the distance between them. So we need to solve the distance for both the parents and the coach. All right. So boom, boom. So we need to solve these two. All right. Now let's get on with it. All right. So to solve for the distance between the parents and the base over here, right? that would be 10 30 degrees, which is, you know, this here. So 10 is opposite over adjacent, so 10 over what we want. So tan 30 equals 10 over x, let's just call it. Right, this is x, this is y, the distance. So in this case, we need to solve for x. So x equals 10 over tan 30, and approximately x would equal 17.3 meters. So this side is 17.3 meters. Alright, basic trigonometry, easy stuff. Now to solve for the coach, so P, C, okay, so solving for the coach would be tan 38. You know, we could have solved this using a special triangle, but we needed distance in meters, so I just plugged it in the calculator instead. So tan 38 in this case, it would be the same thing. Tan 38 equals 10 over y this time because we changed the variable name, and y would equal 10 over tan 38, and y would equal 12.8 meters approximately. Alright, so now it's good and dandy. We have this as 17, that the coach's side is 17, sorry, the parent side is 17.3 m, and the coach is 12.8 m. Alright, so now that we have these two and we have that angle, we can use the cosine law to solve for the distance between the coach and the parent, because the cosine law can solve side angle side SAS questions. Alright, so my camera decided to die in the middle as I was doing the end part of the question. So instead of rewriting it, I'm just going to explain it. So what we did at the end was that we were going to use the cosine law to solve the distance between the coach and the parent. So what we did here is we plugged, since cosine law equals c squared equals a squared plus b squared minus 2ac times cosine of angle c, we just basically put the entire law in a square root, so we don't have to square it out later again. And we just called the distance cp because c and p, the distance between them, you know. So then we plugged in the values, which is 12.8 squared, which is this side, plus 17.3 squared minus 2 times 12.8 times 17.3 times cosine of 105, which is this angle over here, in order to solve CP, which equaled approximately 24.1. So we wrote a therefore statement that says the distance between the parents and the coach is 24.1 meters approximately. Alright, so I hope you enjoyed this sort of tutorial. We learned how to use the sine law, cosine law, trigonometry, the Cartesian plane and the different quadrants. We learned how to solve for the ambiguous case of the sine law, and yeah, we solved all these questions. So yep, thank you for watching. My name was Ali, and I will see you guys later.